Hi gang, welcome to 2.6 called Families of Functions. What we're doing in this section is taking some function, it may be a linear function like we just had, and moving it about the XY coordinate plane. You might shift it left or right, you might move it up or down. Those are called either vertical translations or horizontal translations. But there's some other things we're going to go over. We might stretch it vertically, which means, if you can envision like maybe you got a piece of taffy and you grab above it, below it, and you pull, and could you imagine how that gets, it looks skinnier, but then it's taller? Or we might compress it. If I took that same taffy and tried to push it down, and then it would look shorter, stouter, wider. Okay, we're going to go over the vertical stretches and compressions. We could also look at horizontals, but we're going to avoid that in this course. You can do that in a future math course if you pursue that. So the other thing we'll do is reflections in either the x-axis or the y-axis. So those are the things we want to cover. It applies to almost every chapter we do, so make sure you get this down. It's going to keep coming back, 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 and back again. So let's just take a quick look. If I want something to go up and down, I simply take my function, whatever it is, at f of x, and I add or subtract something. And that'll change the y. That'll move it up and down. So if I want to go 2 up, I simply would add 2. If I want to go 2 down, I would subtract 2, which is the same as adding a negative. Horizontal is trickier. Horizontal is you want to change the x. So you see how it says h is greater than 0 over here? H is greater than 0. If you want to go right, you actually would take your x and subtract 2. If you want to go left, you actually add 2. And I'll try to make sense of that. That's typically the hardest thing about this, is trying to wrap your head around that. I'll try to make sense about that as we get down to our example down below here. Okay? Stretches and compressions, simple. They're basically the same thing. You're just going to take a number and multiply your function by it. If your number that you multiply by is greater than 1, that's going to stretch it. That's going to make your y bigger. Okay? So let's say that you plug in an x and you get y as 1. Well, if you had a vertical stretch of 2, your y would turn into 2. It would be twice as big. Okay, so that stretches it up. Make sure y is bigger. If you use a fraction between 0 and 1, or actually it could be negative. If you had a negative, that would be a combo. So you had a negative and a half in front of here. That would also be a compression, but it would be a reflection too, which I'll talk about in a second. But if your number in front is a fraction, that's called a compression. That's going to cut your y's into smaller parts, or a smaller value. Okay? All right, reflections. If you want to reflect in the x-axis, I'll say over the x-axis. That would look like this. You got a number up here, or a dot right there. If you move it down, reflect it over, then what happens is your y's switch signs. So you've got that that point right here might look like, maybe it's 3, 2. This point right here would be 3, negative 2. The y switch signs. So if you want to reflect in the x, you just make the whole function negative. You switch all the signs of the function. Versus if you want to reflect in the y, then if I have a starting point here, reflect it over the y or in the y, I'm going to end up just as far over to the left as I am to the right. So maybe this one right here is, I don't know, I made it kind of a square, so that's not great, but let's just pretend it's 2, 1, and then this one would have to be negative 2, 1. So you switch the x. You plug in a negative x. So instead of plugging in x, you plug in negative x. So instead of plugging in 5, you plug in negative 5, and that'll flip it over the y-axis. Okay? So those are the 4 main things we want to have down today. Let's take a look at how it works in the graphing calculator and really try to make sense of that horizontal translation. Okay, so we got y equals x squared. If I wanted to make a table, I didn't have a graphing calculator, typically we just start by plugging in these numbers here, -2 to 2. That's what I had to do back in the day when I didn't have a graphing calculator. I always had to figure out what should I plug in. So I'm going to look at what the graph looks like. Well, if you plug in -2, -2 squared is +4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. If you graph these points, probably going to recognize it, you get what's called a parabola. And this is the quadratic function. This is a quadratic. Quadratics we'll cover in detail in chapter 4, but you don't need to really know that it's a quadratic now. You just need to know, okay, what does it look like? And if you didn't know by plugging in some points, you could figure it out by looking at the graphing calculator, which is right here. Okay, so I got y equals, I plugged in x squared. If I look at the graph, there it is. If I look at the table, that's second graph. And that'll show me the points that I just graphed. You can see the top one in bold is -2, and to the right of it is 4. And then below it is -1, 1, 0, 0, 1, 1, 2, 4. The points I just graphed. Okay? All right, so what happens if I add 3 to it? Well, based on what I said at the top in our directions, I said that if you add or subtract at the end, that's going to move it up or down. So that should simply move it up 3. Let's check it out. Let's go to y equals. I'm going to go to y2. X is to the right of the alpha key. Squared is 3 down from the alpha key. I'm going to do +3. Now, if I look at the graph, there's the first one. Here comes the second one. You see it moved it up 3. It's easier to see that it went up 3, or even more easier, I think, if you look at the table, because you can see that the y's changed by 3. Can you see that the 4 under the y1 at top? I can't write on this one. Well, I guess I can, okay. I think that's new. But anyways, there's a 4 there. You see that now it's 7 on the right. Okay, that's 3 up. It went from 1 to 4. That's 3 up. It went from 0 to 3. That's 3 up. All the y's changed. And y is up and down. Okay? So what would happen if I subtracted 5? Well, that should move it 5 down. I'm just going to change my +3 to a -5. -5. Graph. Here comes my parent function graph. And then my transform graph should be translation 5 down. And you can see that bottom point, which is called a vertex, is 5 down. If I look at second graph, I can see all the y's are 5 down. 4 minus 5 is -1. 1 minus 5 is -4. 0 minus 5 is -5. All the y's changed. Okay? So if you add or subtract at the end, you're simply moving it up or down. So this is 3 up. This is 5 down. Okay? Well, here's where it seems to get tricky. What happens if you put a +1 in the parentheses? Notice there's a square on the outside. Well, that +1, I'm telling you, actually means you're going to go 1 left. Okay, now can we make sense of that? Let's see. What happens if I put in x is 1? Well, then I get 2 squared, right? If I plug in x is 1, I get 2 squared, which is 4. So now when I plug in 1, I get 4. Well, before when I plugged in 2, I got 4. Now when I plug in 1, I get 4. So you see my new function move to the left one? My original function, I plugged in 2 to get 4. Now if I plug in 1, I get 4. Okay? What were to happen if I plugged in 0? Well, 0 plus 1 is 1, and 1 squared is 1. So if I plug in 0, I get what's right here, 1. So it used to be where I plugged in 1, I got 1. Now when I plug in 0, I get 1. So my new graph gets moved 1 to the left, and then everything else will look the same. Okay, let's plug it into a calculator to make sure. So I got to put it in parentheses. Let's see, let's go with a second delete. That'll allow me to put a left parenthesis. I got plus 1. Let's see, square's got to be on the outside. I'll delete this stuff here. I'm saying that should look like it's 1 left. So if I graph it, I should get that blue initial one. There it is. And now the red one should be the same thing, only 1 to the left. Okay, so that's the main thing to get used to, is if you have a number with the x, it actually does the opposite to the graph. So plus 1 makes it 1 left. And then you can see that table, second graph that I was working on there by hand. It's a little bit harder to see it here, but here 1 is 4. Here, well, let's see, wait a minute. And it's harder because I don't have the x here. So it's a little bit harder to point out what's what. So here, let's try it again. Here, when I plug in 1, I get 1. And then on the second one, I plug in 0 to get 1. Okay? So here I get 1 to get 1. On the red one, I plug in 0 to get 1. That would be the way to look at it. Okay, let me move down here. Here I plug in 7 to get 49. On the second one, I plug in 6 to get 49. So my whole graph gets moved to the left one in order to stay at the same heights for the y's. Okay? I hope that makes sense. If not, bring it to my attention. We'll discuss it. Like I said, this comes up over and over and over again, so we've got to get it done. So the next one here says minus 2. So hopefully you're thinking that it's the opposite with the x. So if I minus 2, it's actually going to bring the whole graph 2 to the right. That'll offset the minus 2 that you're applying. Okay? So up above, let's see. Let's say x is, I don't know, 2. If you plug in x is 2, you're going to get 0 squared, which is 0. So down here, you plug in 2 to get 0, and up here, you plug in 0 to get 0. Okay? So 2 is 2 to the right of what I had up there. Oops, didn't mean to get rid of all that. Put that back there quickly. So here, if I were to plug in, say, 3, I get 1. So here, when I plug in 3, I get 1. Up here, I plugged in 1 to get 1. So that's 2 to the right. Okay, and if you want to verify, y equals, here's this stuff here. We're doing x minus 2. Should be able to just type right over this. So minus 2 graph. This time my red graph should go 2 to the right. Okay, well, what if you got more than one thing going on? Because one goes left and right and the other one goes up and down, it doesn't really matter which order you tell me, but I would put it in order of operations. So if I said, describe what's going on using the order of operations, hopefully it'd say, okay, I'm going to look at the parentheses first. And because the x has a plus 3 with it, that means go 3 left. And then now there's a plus 1 at the end. And that's not the opposite. That's going to take whatever value I start with here and just make it go up 1. So 1 up. What do you think f would be? It says x minus 4. It's the opposite, so we want to go 4 right. And then minus 2, that's not in with the x, so that's a straightforward 2 down. And again, you can plug that in your calculator and verify, plug that straight in there, and compare it to y equals x squared. You should see that it's 4 right and 2 down. So I want to show 4 right. It's x minus 4 and 2 down. If I graph it, everything should shift to the right and down. Okay, all right, so that's what the add subtract does. That's your left, right, up, down. What if it's multiply? If we go back to the top and go with what I said up there, we realize that when there's a number in front that's bigger than 1, that's called a vertical stretch of 2. And all it does, it changes your y's. It multiplies all the y's by 2. I'm going to clear that one out. 2x squared graph. So when I stretch it vertically, it should get skinnier, right? The red one's going to be inside the blue one. Right? See that? All the y's are twice as high as they were before. You can see that looking at the table. Second graph. You see how the y's changed? Here x is negative 2. The first y is 4. The second one's 8. It's twice as big. So we're multiplying by 2. Here we go from 1 to 2. Multiply by 2. 0 to 0. Multiply by 2. 64 to 128. Multiply by 2. That's called the vertical stretch. If it's a fraction between negative 1 and 1, that's called the vertical compression. This one at the bottom is a vertical compression. Of a half. That's just going to cut all your y's in half. Divide by 2. It's going to make it look wider. Okay, so instead of 2x, we want a half x. So we can make it 0.5x. Second, delete, so I don't erase my x there. Put a 5. Oops. Get rid of one of those. So that's the same as a half x squared. If I graph it, now my red one should look wider. It should look like it got pushed down, flattened out. You could also, I said this would be for a future class, but you could also describe that as a horizontal stretch. Okay, you could say it got pulled left and right, but we're focusing on the vertical in this class. And if you look at the table again, you can see your second y's, your red y's are half the size of the blue y's. Okay? Hope that's making sense. All right, on this side, then we're going to focus on reflections. Those are probably about as tricky as the left and rights. So we seem to get the students seem to get the reflect over the x or in the x pretty easily, but the y, that could be a little bit of a mess. So let's take a look at this. So we got graph f of x equals x cubed minus x squared on your calculator. I don't even know what that looks like, so don't think, oh, I don't know what the heck that is. Who cares? Just put it in here. See what it looks like. So let's clear out these right here. We got x is to the right of the alpha. Cube, you got to hit the caret key above the division. Want x cubed minus x squared. All right, let's see if that shows up on our regular screen. Negative 10 to 10, negative 10 to 10. Okay. All right, so that's what we're going to mess with. I don't know how you describe that. It's got a couple of bends in it, looks like. Okay, goes down as you go left and up as you go right. That's another way we could describe part of that. Let's see, look at the table and copy the graph onto the given coordinate plane. So I'm going to try to move this over here. Oops. This down first. Okay. And then I'm going to do a second graph, bring up the table. All right. And then some points on there would be -2, -12, -1, -2, 0, 0, 1, 0, 2, 4. Okay, so let's see if we can plot some of these. Well, -2, -12, I guess isn't going to fit. -1, -2 would be right here. 0, 0, 1, 0, and then 2, 4. And the other one's going to be 3, 18. That doesn't work, so it's something like this, anyways. Okay, it doesn't have to be perfect. We're looking at reflecting it, so we just want to see what happens. All right. What function is a reflection of f of x over the x-axis, or in the x-axis? Plug it into your calculator to verify visually. Well, when you want to reflect over the x-axis, I mentioned that earlier, that simply takes this point here and moves it down here. Okay, so instead of being at 2, 4, we want to be at 2, -4. Now these aren't going to move. And instead of being at -1, -2, we want to be at -1, +2. Okay? And instead of, well, I guess that's kind of what I had. So what I want to happen is for it to look like that. That is a reflect over the x-axis. Now, it looks like a reflection of the y-axis too, but we'll have to see. Okay? That's reflect over the x-axis. You got to envision a line of symmetry going right here. So think about a butterfly, and you got your head kind of facing this way over here, whatever. I'm sorry, I'm no artist. Okay? So, how do you do that function-wise? Well, you want the y's to change. So what I said earlier on is if you want the y's to change, you're simply making the function negative. So you're making the function negative. So put a negative in front of the whole function, and you actually end up with -x³ plus x squared. Excuse me, plus x squared. So that should be the transform function, -x³ plus x squared. And let's try that in the calculator here. So I'm thinking -x³, x cubed, arrow to the right, plus x squared. Let's see what happens. Okay, that's what I was looking for. I was hoping to flip it over the x. Looks like it did just that. It does not look like it's a reflect in the y-axis, because it looks like the blue over here is further away than the red over here, right? This is not the line of symmetry. That doesn't look right. So it definitely does not look like it's reflect over both. It looks like it's reflect just over that x-axis. Okay? And if we want it to reflect over the x-axis, let's look at the table and see what happens. Okay, so how can we show that that worked? Well, here I plug in 2, on the blue one I get 4, on the red one I get -4. Here I plug in -1, I get -2 on the first one, I get 2 on the second one. You see how they're just opposites over there? And that's what I want. I want the y's to be opposites. So if you want to reflect over the x-axis, just switch all the signs in the given function. Okay, so we had that. We could call our new function g of x just to be different. That's the one that does it. Okay, what function is reflection of f of x over the y-axis? Well, now we want the x's to be different, so this is where it's kind of tricky. F of x was x³ minus x squared. I want to plug in opposite x's and get the same y. Right? Like, let's say this is a point here. When I plug in 3, I get 1. To reflect it over the y-axis, when I plug in -3, I want to get 1. So the x's need to be opposites. Here it's -3, here it's 3. I need them to be opposites. So all I do is plug in -x. Just like we did early on, when you plug in for a variable, make sure you use parentheses around what you plug in. So I plug in -x. Now if I simplify that, I get, and I'll call this one, I don't know, I'll call it h of x, just to be different. What's -x cubed? Well, there's 3 negatives, so it's still -x cubed. And then my order of operations tells me to do this part next. What's -x squared? Well, it's 2 negatives, which makes a positive. So it's positive x squared, except there's a minus in between it. So -x cubed minus x squared should be the function that reflects it in that y-axis. Let's see if it worked. Equals. So it's -x cubed. I'm thinking it's minus x squared. Okay, let's just look at the graph and see if that has a line symmetry of x equals 0, which is the y-axis. I'd say that looks pretty darn good. I would say that the y-axis looks like a line of symmetry right there. And when I plug in opposite x's, I want to get same y's. So let's go second graph. When I plug in opposite x's, I want to get same y's. So when I plug in -2, on this one I get 4. Here, when I plug in 2, I get 4. When I plug in opposite x's, I want to get same y's. On the second one, when I plug in -1, I get 0. On the first one, when I plug in 1, I get 0. On the second one, when I plug in 7, I get -392. That means on the first one, when I plug in -7, I should get -392. So when I plug in -7 on the first one, I should get -392. Let's check it. Go to -7. Look at that. Here I plugged in -7. I got -392. That's what I wanted. When you plug in opposite x's, you want to get same y's. That means you reflected it successfully in the y-axis. What function translates f of x 3 up and 2 right? Plug it in your calculator to verify visually. Okay, this is kind of tricky. So we start with f of x equals x cubed minus x squared. To go 3 right, I need to change the x's. So this is, most students would miss this, if not all, I think, for the first time. You need to change these x's. You need to change both x's. I want to go 2 to the right. 2 to the right. Well, 2 right, I need to do the opposite. I need to go x minus 2, right? Remember that? And it needs to happen for both of these. So I'm going to have x minus 2, that quantity cubed, minus the quantity x minus 2, that quantity squared. And now I want the whole thing to go up 3. That's what I think does it. So when you want to go left and right, you don't just change any one x. You got to change all the x's. Let's see if I got it right. I got my parent function up top. That's what I want. Down here, I'm just going to clear that out. Go parenthesis. X minus 2. I want to go to the right. Quantity cubed. Minus parentheses. X minus 2. Quantity squared. I think that makes it go 2 right. Let's just look at that. Let's see if it went 2 right. There's our initial one. Hopefully for the next one, looks exactly the same. It's just slid over to the right. That looks good to me. And now I think that if I put a plus 3 at the end, it'll get there eventually. Right there, plus 3 should make it all go up 3. Okay. So if I put a point right in here, if I slide it over 2 and up 3, hopefully see I'll be back on that graph. Okay. All right. What function translated 5 left and 2 down? Give that a shot. Pause it right here. Give that a shot. Check it out. I'll write the answer. Give it a pause. Okay. Hopefully you paused it, you wrote it down to check it out. We want to go 5 left, so we actually got to add 5 to x. And not just one of them. Every x that's in the problem. Want to go 2 down? Yeah, let's put a minus 2 at the end. Okay? Hopefully you did that on your own, you got it. Hopefully you checked on the graphing calculator to visually see that that's what gets this done. This stuff is that important, it comes up over and over and over again. Okay? Then here's some examples of test questions that you would have. Pretty much goes hand in hand with what we did. I would challenge you, go ahead and try to give these a shot. The first one though, I didn't really do any examples of this, so you might want to just watch this one. I think the next 2 you should be able to get from what you saw in the notes. Okay. So the first one, we're going to do order of operations. So I'm going to look inside the parentheses. Notice these are both functions that have x to the 4th or something to the 4th. So I'm not sure what that looks like. I am really, but you could plug it in your graph. You don't know yet. You haven't covered x to the 4th. Those are called quartic functions. You can plug it in, see what it looks like. I look inside there, x plus 3 tells me that this thing is going to go 3 to the left. You can either do that first, or you can just go left to right. Whatever you do, don't do that minus 5 until the very end. Okay, so if you want to do parentheses, great. And then they're going, hey, I'm multiplying by negative 2. We've got to deal with that. But you got to be careful that multiplying by negative 2 is actually 2 different things. The negative in front, that tells you that you're dealing with a reflect over the x, because you're changing the x to the 4th to a negative x to the 4th. So I'll say x to the 4th is 8. Then negative x to the 4th is negative 8. Okay, x to the 4th is what you get for a y. So instead of y being 8, it'd be negative 8. So it reflects over the x-axis or in the x-axis, either way. And that 2 is actually a vertical stretch. So you got 2 things going on there. It's getting stretched out because there's a 2 in front, and the negative tells you that it's a reflect over the x-axis. And this order does matter in that the minus 5, you got to give that description at the very, very end. So 5 down. Another correct answer would be if you gave me these 2 things right here first. Describe those first. This one second, this one third. I mean, you could actually do first right here again. You could do 5 down second, and you could do 3 left third, because left has nothing to do with down. But I would just go in the order, just be consistent, order of operations. So work with the parentheses, deal with the multiply out front, deal with the add and subtract last. Okay? These next 2, I'd encourage you to give a try and check your answer. 2 left is x plus 2. 3 up, add 3 at the end. Reflect over the x. Sometimes I got to think about it. Reflect over the x is like, okay, I want here and here, so the y's got to be opposite, right? I need, if y, right, say this one here is 3, 2, this one's 3, negative 2, the y's have to be opposite. If I want the y's to be opposite, I just switch the whole thing, Because here y is 5 minus 2x. Down here y would be negative 5 plus 2x. So if you want to go in the x-axis or over the x-axis, just switch all the signs in your business. Okay? If I want to go to the y-axis, remember what to do? You plug in negative x right here. Okay? And go to the y-axis would have been 5 plus 2x. So those would make a positive 2x. So, kind of a long lesson. I hope you understood. Very important stuff. Going to keep coming up. Make sure you get your questions to me if you have them. Thanks for watching. You have a great day.